Hello, this is Audrey, and in this video I will be speaking from the journalism side of my studies and be teaching some basic principles around communicating data effectively. So obviously a powerful way we communicate data is visually. In DataViz we're presenting nominal, ordinal, or quantitative data, and there are different visual variables that are best for presenting each type. As a quick review, nominal means names, ordinal is names but with some sort of ranking involved, and quantitative is numbers or measurements. Going back in time, Jacques Bertin was a French cartographer and geographer who wrote a book in the 60s called The Semiology of Graphics, which ended up being extremely important to the field of information visualization. In his book, Bertin proposed 7 visual variables for encoding data and began to theorize about their effectiveness for representing different types of data. The 7 variables Bertin proposed are position on the x and y coordinate plane, size, value, which kind of means shading, color, texture, orientation, and shape. It's important to note that 3D space is not included in his list, neither is time, and with today's technologies available for making data visualizations, both of those can be pretty effective ways to encode data. So building off of Bertin's work, a guy named Jacques Macinlay was particularly interested in what encodings were most effective at communicating data for each variable type. Now he looks like this, and he's the vice president of research and design at Tableau, the Glow Lab. But this is the chart he came up with. So, for example, quantitative data is best communicated through position, then length, then angle, and so on. Color is not an effective way to communicate quantitative data, but is very effective for nominal data. That might seem intuitive, but there are a lot of pretty bad graphs out there. So keeping these criteria in mind as we're making our graphics, when it's time to assess them, there are kind of 2 criteria to keep in mind, both proposed by Jacques. One being effectiveness and the other expressiveness. They sound similar and also seem kind of obvious, but they're really important for assessing the quality of your data visualization. Expressiveness means that the visualization expresses all the facts and only the facts in the data. For example, if you were to use size of bars to visualize nominal data, it would imply something about the nominal data that isn't true. The increase in the length of the bars, for example, doesn't actually correspond to anything in the data. So that would be an example violating expressiveness. And effectiveness means that the information is conveyed in a way that is the most readily perceived. So that takes us to a little bit of research on human perception, which I thought would be a fun way to end this video. So here are a couple of fun exercises, kind of demonstrate what type of research goes into assessing human perception of data visualization. So think about the answer in your head, and then I'll say the answer. So, how much longer is B? It's 2 times longer. Now how much longer is B? 4 times. How much steeper is line A? 4 times. How much larger is circle B? It's 5 times. How much larger is circle B now? 2 times. How much darker is circle B? 2 times. Now how much darker is circle B? It's 3 times. So you might have gotten all of those right, you might have gotten most of them right, but the point being that not every person is going to get all of those right every time. So it's really important to think about how easily the information that you are trying to convey is going to be perceived by the viewer, and how accurately. Thank you for watching my video. I hope that you learned something, and I am excited about the future of the quarter.